With a jet of air, Mirabeau spins the tiny spacecraft like a top to give it added stability.
10 seconds. Copy, 10 seconds. 5, 4, 3, 2, 1, fire!
The laser beam is made up of infrared light. As the beam pulses, it strips air molecules of their electrons, creating an explosive plasma that propels the craft from below.
How about that?
Nice catch.
What do you figure, 40 feet?
Yeah, that was about 40 feet.
40 feet.
Maybe 45.
Ready to go again?
Now I know you were probably anticipating that we would get to this point in the video and I would just end up rehashing some vague government UFO encounters and show evidence displayed in countless other documentaries over the years. I'll take responsibility for doing that in the previous video, as I scattered a couple random photos in the video of suspected UFOs that I wasn't specifically talking about. Despite that, I wanted to do something different here. In this video, I intend to not drag out this story further with glimmers of truth the way that plenty of other filmmakers have done, honestly, so disgracefully. So I've taken the liberty of sifting through a 525-page declassified document released by NASA and the BDM Corporation in May of 1983, titled Advanced Beam Energy and Field Propulsion Concepts. It was the final report in which the BDM Corporation conducted extensive research for NASA and gave serious consideration to the chief scientists, Leac Mirabeau and Franklin Mead's laser-powered propulsion systems of the 1960s. Apart from laser propulsion systems, NASA was also interested in testing different conventional nuclear or chemical combustion engines, for instance, that would coincide with the experimental propulsion systems. But don't just take it from me. Instead, let's pull directly from the source so you can get a better understanding of the contents that have been sitting in this document for 42 years. According to the abstract of this monumental NASA document, the report focuses heavily on advanced propulsion spin-offs enabled by current government-funded investigations in directed energy technology, such as laser, microwave, and relativistic charge particle beams for post-2000 propulsion concepts. To warrant inclusion in the study, the concepts must be sufficiently developed to permit technical understanding of the physical processes involved, assessment of the enabling technologies, and evaluation of their merits under conventional systems. The study includes investigations of propulsion concepts that can be used for manned and/or unmanned missions for purposes of solar system exploration, planetary landing, suborbital flight, transport to orbit, and escape. Speculations are made on the chronology of milestones in beam energy propulsion development, such as in systems applications of defense, satellite orbit raising, global aerospace transportation, and manned interplanetary carriers. Aside from reading you the abstract to this fascinating document, the chapter titles alone would intrigue anyone enough to skim through the entire thing. But to prevent this video from taking up your entire day, I've composed a comprehensive list of what the chapters discuss, and they include content ranging from power beaming technology for laser propulsion, design considerations for laser-propelled shuttlecraft, either more specifically through laser thermal air-breathing propulsion systems in delta, radial, and cylindrical configurations, or through air-breathing laser electric propulsion systems incorporated into radial shuttlecraft and cylindrical configurations. Additionally, the document encompasses a chapter on the performance evaluations of single stage to orbit, or SSTO, radial shuttlecraft. SSTO vehicles refer to craft that are able to take off from the ground and achieve orbital flight without expending vital components like fuel tanks, rocket boosters, and entire engines. Prime examples of space vehicles that required these external components were NASA's Columbia and Challenger space shuttles. The NASA and BDM Corporation's document also discusses the monocle shuttle, or SSTO, laser relay craft. Even though everything I mentioned thus far has been exciting to uncover, and I'm sure interesting to hear, perhaps the most intriguing portion of the document that genuinely shocked me when I read it were the chapters covering the electrostatic propulsion concepts, near-term plans to construct manned space battle cruisers, and far-term plans to develop interplanetary carriers. Unfortunately, I won't be able to provide you with a deep dive into everything in this one video, partly because I don't fully understand the mathematical and physics equations, along with the graphs thoroughly discussed in the document. However, you should know that some of the schematics displayed in this document depict several concepts that look less like classical UFO designs from Hollywood films like Jordan Peele's Nope, and more like spacecraft designs seen in George Lucas's film franchise Star Wars. Both are fictional, yet seem like they draw from some pretty real things. This would be especially true when the document delved into any concepts where the craft would have to be constructed in space, within Earth's orbit, of course. Now that I've provided you with a brief synopsis of what the document included, I think we can finally zero back in on our story surrounding New Mexico and the small town of Dulce. When Mirabeau began his experiments during the 1960s into what he called his laser-powered light crafts, they were conducted at the Los Alamos National Laboratory, but Mirabeau and Meade's experiments were never isolated around Los Alamos. Kirtland Air Force Base and the Manzano Test Range would later become the home to many of these laser-driven experiments, and it would eventually give Paul Benowitz a front row seat to the action flying over the mountain in Coyote Canyon. Unsurprisingly, other testing facilities had also adopted some of these laser-derived covert programs, such as the naval test site called China Lake in California. Before moving on to the craft and systems themselves, it should be noted that the BDM Corporation was later bought out by a company called TRW, which would later turn into the famous U.S. military defense contractor Northrop Grumman. According to Lieg Mirabeau, in his initial laser-dependent lightcraft experiments, they used a variety of propulsion modes to provide specific aspects of desired flight characteristics. To be more specific, though, it utilized 3 different modes depending on the task. The first system to discuss is in the ion propulsion mode. This mode is used in tropospheric low speed or subsonic transportation scenarios and is mainly for takeoff and landing purposes. The propulsion mode uses an array of solar cells attached to the hull on one side of the light craft, coordinating with the monocle relay shuttle and orbital transfer vehicles to achieve its desired task. It should be noted that the energy beam receptors on the relay craft were likened in the documents to the light receptors of an insect's eye. The second mode is referred to as the magneto-hydrodynamic propulsion mode. The MHD propulsion mode is described to be utilized during orbital flight and is tied to the third mode of propulsion, the pulse detonation engine mode. Perhaps I should have mentioned this earlier, but orbital flight refers to any craft movement beyond Earth's atmosphere and can extend to distances beyond satellites and the International Space Station. Think more so about craft capabilities that can make distances such as reaching the moon a breeze by comparison to the Saturn V rockets that were used to hurl the Apollo spacecraft to it. The PDE system is important because it is used to propel the light craft into the magneto-hydrodynamic system, which is required for the craft to transition between subsonic, supersonic, and hypersonic flight. If you were unaware, subsonic flight refers to speeds that range from approximately 767 miles per hour and under. Subsonic flight will never breach the sound barrier. Supersonic flight then does the opposite and exceeds speeds faster than sound can travel. This is ordinarily accomplished when aircraft surpass a speed of anything greater than Mach 1.1, yet below Mach 5. When the sound barrier breaks, the craft's speed will generate an extremely loud sonic boom that'll reverberate throughout the nearby area. In the purview of this discovery, it should be noted that the military, along with various agencies, had spent a significant amount of time and funding to turn this sonic boom from a byproduct of supersonic flight to a potential weapon that could be used against enemy ground troops and equipment. Hypersonic flight, though, as a concept, is very much still in its infancy with the public. The key words there are with the public. These covert invisibility systems, depending on the craft, could either fully cloak the aerial vehicle with the sky behind it, making the craft fully invisible to the naked eye and advanced radar systems, or alternatively, the active camouflage system could make the craft appear semi-translucent. Regardless of the variation in active camouflage capabilities, the ultra-secretive crafts will appear as visible light orbs to anyone that's lucky enough to observe them in flight. It should be mentioned that these lights are repeatedly observed to be visibly generated during most lateral and vertical movement of these secretive craft. When moving at slow speeds comparable to a car or when idly hovering, it's been observed that these crafts can shut off their lights entirely while also remaining transparent in the sky. These crafts do this by storing energy that's passively collected during flight. So if these experimental crafts ever manage to find themselves in a precarious situation within enemy territory, then they would be able to use this stored energy as a supplemental propulsion and cloaking system. When it's activated, the secondary or tertiary propulsion system will emit a low humming noise, just like the craft that Gabe Valdez encountered with the tribal police officers in the gas buggy area. Both the PDE and MHD systems are powered through orbiting satellites called orbital transfer vehicles. It's important to make the distinction that these OTVs are entirely different from the monocle shuttles or single stage to orbit laser relay craft. Depending on the distance, these satellites would send a precise laser, microwave, or millimeter wave that would link to the spherical relay craft. The relay craft would then send the beam signals to something that's called a transmitter mirror. The beam reflecting off the mirror is then meant to hit a specific portion of the craft's hull that acts like a built-in antenna. All of this, in turn, allows the shuttlecraft to fly. The magneto-hydrodynamic propulsion on the craft would either vaporize water or liquid metals like mercury as a cooling system for the engine. To tie this back to the story of New Mexico and Dulce, Paul Benowitz had mentioned in his notes that it appeared the crafts were using the Navajo River and dam as a refueling source to cool these said engines. Moreover, I should also mention that the light craft Paul filmed and photographed were significantly larger than the prototype you observed during the clip of Mirabeau's early laser propulsion experiments. The hull of the light craft is reportedly able to support its weight through an exterior metal tube that is wrapped completely around the craft and is filled with a mixture of helium and oxygen called heliox. The NASA report refers to experimental concept crafts, such as the one being described, as lighter than air vehicles, or LTAVs for short. This mixture and others similar to it aid in making the aircraft functionally buoyant in the atmosphere and are apparently used as safety flotation devices for the onboard passengers of the shuttlecraft in case of an emergency. On a separate note, many of these experimental craft would either use auxiliary tripod landing gear or they'd use a system called a maglev lander. This maglev lander system uses a combination of magnets and laser components to act as a landing peg for the craft. Add two more and you have a stable triangular system. Allegedly, this system is also used like a straw for refueling the spacecraft with coolant. Oddly enough, the magnetic levitating systems are mainly used in the radial and cylindrical configurations of these craft. This was primarily due to their capabilities and sole reliance on vertical takeoffs and landings, which was a feature that most Delta configurations couldn't afford to have. VTOL systems aren't new and have been utilized in aircraft other than conventional helicopters for decades, such as the V-22 Osprey, the McDonnell Douglas AV-8B Harrier II, and the F-35B Lightning II. Another aspect of these light craft that reminds me of a classical UFO vehicle is its capabilities to magnetically attract or beam objects up into the aircraft using what Mirabeau called a maglev belt. You'll have to do more research on your own if you'd like to know more about this magnetic levitation technology for the craft. The main thing that you need to know about these laser-propelled aircraft and spacecraft, sometimes called transatmospheric vehicles, is that they require a substantial amount of external power to run the lasers themselves on the ground. It's said in the NASA and BDM documents that a large network of mountaintop installation facilities would be needed to provide the appropriate space to produce enough energy while also maintaining a clear signal to the satellite vehicle and shuttlecraft. According to Mirabeau, there would be distortions and substantial atmospheric decay of the beam signals if the large subterranean power station antennas were set at lower elevation for the sake of ease regarding their construction. Remember that everything had to be built by someone, and allegedly Lockheed Martin and Boeing were some of the companies contracted for the production of parts for this entire logistical process. At the very least, those companies were responsible for the production of the orbital transfer vehicles. According to Greg Valdez, it seems that the defense contractors had renamed the project to Space Station Freedom for whatever reason after acquiring the contract. For those wondering, a shuttlecraft is the terminology used in the NASA and BDM Corporation's documents to refer to the manned craft, while the term light craft was personally used by Liek Mirabeau and Franklin Meade. Another necessity for these vehicles to fly meant that the labs and military needed to install linked transmitter mirrors along the ground where these experimental craft were rumored to fly. These mirrors were intended to reflect a free electron laser's energy and intensify its directed beam to an extreme degree to make contact with the laser-based craft. I guess you could think of the mirrors as reflective energy boosters when the craft would fly farther away from the substation. These transmitter mirrors ensure that the aircraft or spacecraft receives the appropriate amount of directed proton or electron energy from a monocle shuttle that's needed for it to remain in flight. While we are on the topic, it's theorized that the pylons I mentioned earlier in passing, which Paul Benowitz had photographed from inside his plane and Dulce and informed Gabe about, were really these transmitter mirrors. The concept of linking the transmitter mirrors to scattered power stations aligns with the countless accounts of people witnessing these experimental craft flying around these mountain ranges close to government labs. It could also explain why these unique aircraft fly in specific routes through many Native American reservations, as they need to remain in range of these mirrors. By extension, the substation antennas need to have the best available signals on mountaintops like Archuleta or Manzano to be able to have minimal atmospheric decay with the guided orbital transfer vehicles floating around in space. Aside from this brief introduction into the light craft and how some of these laser propulsion systems work, there are other methods of propulsion discussed in the declassified documents, with the most notable being the electrostatic propulsion concepts. These are systems tied to relativistic charged particle beams, and thankfully they do not require all of the underground power generation facilities and transmitter mirrors that the other laser-propelled shuttlecrafts depend on. Instead, these crafts are able to change their electromagnetic charge to positive, negative, or neutral depending on the desired task. To give you an example, if the electrostatic craft had a designated landing position, then when it reached that point, it would seamlessly shift its electrical charge from positive to neutral. By the same token, if the pilots of the shuttlecraft desired to move in a particular direction, the whole of the craft would generate a positive electrostatic charge. What makes the craft so special is that it uses this positive charge to attract itself towards an ionically formed, negatively charged ion cloud. Although the word cloud is used, it's not something that can be seen and is more so used as a visual reference for what's happening at the molecular and atomic level. These clouds are utilized by the electrostatic craft in a couple of ways, to my knowledge. One way these negatively charged clouds are used is when the craft transitions from low atmospheric flight to suborbital high altitude flight. In these situations, the craft will more than likely use a negatively charged ion cloud that's located far above the actual shuttlecraft itself. Essentially, the shuttlecraft would slingshot itself through the use of its particle beam toward the ion cloud to propel itself higher in the atmosphere. Another option would be to neutralize the shell of the craft to enter the negatively charged ion cloud. Once the shuttlecraft has been encased by the cloud, it could then change its electrostatic charge to negative while the craft projects its particle beam in a desired direction. The electrostatic craft then ejects itself from the charged cloud to achieve speeds of Mach 5 and higher. Ordinarily, though, when flying in a fashion that's similar to current acknowledged military aircraft, the shuttlecraft will emit a relativistically charged particle beam of electrons towards a negatively charged ion cloud that the craft generated itself. Bear with me. Once the cloud has been stabilized and the connection has been made, The positively charged craft will then follow anywhere the ion cloud is generally pointing through an electrostatic thrust. I suppose the easiest way I could explain this would be with a horse and carriage. In this particular instance, with the electrostatic propulsion, the horse is the negatively charged ion cloud, and the carriage is the positively charged shuttlecraft, and the shaft that connects both the horse and the carriage is the relativistically charged electron particle beam, or proton beam. Many of the tic-tac and egg-shaped UFOs and other cylindrical craft seen around the world operate under this electrostatic propulsion system, and it's theorized that this was the type of spacecraft seen by Officer Lonnie Zamora during the Socorro UFO incident. The thing about these experimental crafts that made researchers like Liek Marabo refer to them as light crafts is due to what occurs when these crafts move at very high rates of speed. Regardless of whether or not movement is fluid, like a traditional aircraft, or in a pulse manner, like in Mirabeau's initial studies, the effects that are generated remain the same, so long as there's no anti-gravitic technology involved. I state this because those kinds of systems produce a different kind of light that is more comparable to sparks coming off of the craft rather than glowing like a rim or a dome of light that encompasses a portion of its whole. When moments of hypersonic speeds are produced within the atmosphere, a wake is formed around the craft into what is called a ion plasma cone, which wraps around the shell of the craft to the back and produces a tail along the bottom of it. This could explain that image I spoke of earlier when Bill McGarity had brought back the enlarged image from the expedition of the unidentified black aircraft back to Gabe Valdez in Dulce. By extension to this ion plasma cone, the electron beam produced from many of these hypersonic capable spacecraft systems can create bell-shaped ion clouds around the apex or front of the airframe. This bell-shaped wake of light seen on the shuttlecrafts during suborbital flight is not a new concept, and it is referred to as the Bremsstrahlung effect. Before we stray too far from discussing this ion particle beam drive system, though, it should be stated that these electrostatic shuttlecrafts would gather low-powered microwave energy for its engine. The nearly passive microwave collection system provides the craft's engine with the ability to fly silently over short durations. More specifically, the engine does this by utilizing the passive microwave energy gathered and stored in the primary magnetic field called the superconducting magnetic energy storage unit. In reference to the conversions mentioned previously, there are still quite a few other kinds of aircraft and spacecraft concepts that I have yet to discuss with you that's directly from the pages of the massive NASA document. With that being said, many of the crafts still involve the Bremsstrahlung effect formed by the primary or secondary electrostatic systems implemented on these crafts, along with other propulsion methods we've discussed previously. If you'll recall, I had mentioned numerous air-breathing shuttlecraft concepts in the list of content found in the document. According to NASA, the best configurations for these air-breathing craft were radial shaped. That's not to suggest that any delta configurations of these crafts wouldn't work, because they did, and numerous forms of delta-shaped laser thermal, laser electric, and chemical combustion air-breathing aircraft were tested. However, The majority of these Delta configurations worked at their peak efficiency levels when flying at hypersonic speeds, which severely hindered the practical applications of the craft. The reason for this will conveniently circle us back to the Bremsstrahlung effect. Because the Delta-shaped craft mostly operate like conventional aircraft, even occasionally in their takeoff and landing systems, it causes the ion plasma cone to develop at the nose of the hull when flying at speeds of Mach 5 or greater. The plasma generated from this cone is vital, as the plasma itself is pure energy and can be utilized in a different kind of propulsion system. The intended goal for these kinds of craft is to capture that plasma in the hypersonic wake and convert it into energy for the craft's use in high energy consumption scenarios. This fascinating method of air-breathing energy conversion is referred to by the Defense Advanced Research Projects Agency and NASA as a scramjet. Unlike traditional jet turbines with rotating compressor blades that direct airflow into the turbine, the supersonic combustion ramjets utilize ignited hydrogen fuel in a highly compressed supersonic airflow engine that doesn't contain any moving parts. As compressed air passes through the engine and hits the hydrogen fuel igniter, a rapid expansion of hot air occurs and causes it to be pushed out through the exhaust port nozzle in the back of the scramjet, generating immense thrust that can propel the craft to over Mach 10 in high altitudes. What I just described would be classified as a chemical combustion plasma combined cycle propulsion engine. Out of all the aerial technology discussed in this video, the most information can be found online discussing scramjet technology. Apart from the lack of VTOL capabilities, another limiting factor for quite a few of these kinds of delta-shaped configurations, at least with regard to air-breathing craft, are in the fixed intake ports. Simply put, if a craft is built with fixed intake or exhaust ports, then it is no longer capable of transatmospheric flight and must remain inside Earth's atmosphere to function properly, as it relies on its air consumption of the plasma to facilitate the process of generating energy and cooling the engine. That's also without mentioning that crafts which rely exclusively on their supersonic combustion air-breathing engines, specifically with fixed open intake ports, must remain in continuous supersonic or hypersonic flight to function at all.
Well-intentioned regulatory regime of the 1970s became an ever-tightening ratchet, first hampering America's ability to become a net energy exporter and then making it harder and harder to build. We seem to have lost focus and vision, to have lowered our sights and let systems and structures and bureaucracies muddle us along. But we are capable of so much more. Our technologies permit us to manipulate time and space. They leave distance annihilated, cause things to grow and improve productivity.